Welcome to PyMCon. The following is the Q&A portion of Todd Hendricks' talk, Protecting Voting Rights Using PyMC. But if you'd like to see the collab and his recorded content where he talks over the collab, go to pymccon.com or the PyMC Discourse. Both of those will be linked below. With that, we hope you enjoy the talk and the Q&A. So welcome to another PyMCon event. This is for Todd Hendricks and talking about protecting voting rights. And so Todd had shared his video on the PyMC Discourse already. It's about 20 minutes where he talks through the notebook. This is just the Q&A session where we'll be asking Todd questions. I believe folks here will be are allowed to chat, but let's see. I always get mixed up on Zoom. I use Google Meet most of the time. So what I would say is we will be taking questions on the PyMC Discourse. So go ahead and place them there. And then pull it up real quick. And then we'll just get started with the seminar itself. So everyone should have the link to the oops, not that. That's the Zoom webinar. Here's the link to the discourse. We'll be taking questions primarily through there. But what I'll do is I'll start by kicking it off with a couple questions of my own. So Todd, you've gone through a hierarchical Bayesian model, and you use this in protecting voting rights. So the first question I have is right along the lines of the workflow. When you're pulling in this voting data, aside from the modeling, do you need to spend a lot of time checking it for issues, cleaning it, or things like that? Or do you find that you can just take it and then continue on with your modeling?
Yeah, good question. I think the biggest thing I run into is the values, I'm feeding my model of float values. And so each row has to sum to 1 exactly. And if for some reason I didn't process my data properly, the model won't fit. So that's really the biggest challenge. One of the things that I mentioned in my notebook is that my data sets are pretty damn small. So I typically I've got somewhere between 50 and 100 rows maybe. So, I guess the other thing that could trip me up is that not being enough data for, the sampler to get a good feel for what's there. So those are really the two things.
So that brings me to my second question is that when you have such small data sets, although we're Bayesians and we don't need big data to make conclusions, how do you typically then know that you have a strong enough inference to make a conclusion, particularly because you work on a topic that's pretty, I assume requires a greater burden of proof, right? You're working with lawyers, you're working in the legal system, and these things get challenged, I assume, in the legal system itself.
Right.
From these posterior plots that you have, when is it that you feel like this is enough? And then does your perspective of this differ from what the lawyers say and the colleagues that you work with?
Well, the good news is the lawyers typically defer to me on my judgment, and it's really squishy. I guess the rule of thumb for me is if there's any question about not having enough confidence in my estimates, I'll just tell the lawyers, hey, I don't think we should move forward with this. We're going to have to defend it, and we don't want to have to defend it. Most of the time, I shouldn't say most of the time, a good portion of the time, even with a small data set, I'm enough to produce something like this. You're sharing the screen here. When it looks like the purple ridge, that's telling me that I've got, there's probably about a 10% spread in the credible interval there. And so if we're looking at Kolstad in the middle plot, we can be reasonably confident that support from non-Asians is 45%, and it's not going to be much more than, say, 50%, right? And that's enough confidence to support, the types of efforts that we're doing. On the flip side, if my estimates were to look like the green or the orange there, that's when I would definitely tell the lawyer, we don't have enough confidence in our estimates. This is pretty weak evidence.
So let me ask you one follow-up question on that, and then we've got a question from Daniel Saunders, which I'll ask you second. Could you talk me through how you make that conclusion about your inference in more detail? So do you typically do that qualitatively, and that is enough so you can look at these posterior plots and see the distribution across races, or do you need to do more numerical calculation? Good examples like Gelman and others write a lot about t-statistics and these sort of methods to say, like, what's the probability that less than 80% of voters would come up with a certain outcome or something like that, where you quantify it with the posterior samples or other means?
Yeah, that's another great question. And, there's a really famous expert witness who has done this for, 30 years. And I learned from him. And one of the things he says is, this process we're going through in these estimates, we're ultimately using a quantitative means to answer a qualitative question. And so, you use the word qualitative, and that's what, jumped out at me. Ultimately, it is a qualitative thing. When we're doing these estimates, at the end of the day, it's going to have to be a judge who doesn't really know anything about Bayesian models. He's just the judge, he or she is going to have to use their best judgment. And so when I'm doing this analysis up front, what I'll do, in my head, I'm always like, okay, if I have to put my lawyer in a position to where they have to, defend this, and the other side's going to bring in an expert that understands this stuff, it's going to be, I want it to be pretty straightforward. And so that's a long way of saying that it really is a judgment call. Once I produce these posteriors that we're showing here, it's really up to me to, basically tell the story. And, the lawyers are going to defer to me because I've done it enough times. But again, I guess the last thing I'll say is, the types of places that, we typically litigate, there's enough confidence in the estimates, and there's enough separation between these posteriors that we're plotting here to where it's pretty clear cut most of the time.
Got it. This leads into the question that Daniel asked. I'll read it from the discourse here. I was curious to hear more about the history of legal theory and the statistical models developed together. Were lawyers able to argue vote dilution cases before this model was developed, or did cases only get started once somebody worked out the statistical methods? And then to the question that you answered partially now, did the courts have trouble coming to accept the results of this sort of model? So I'm going to break it apart into two pieces. Can you just talk through the history of vote dilution and then how statistical methods grew with it? Or was it statistical methods that are driving vote dilution cases? Like, how did the two interplay, and how has that changed over time?
I love this question. This is just another really good question. So the Voting Rights Act was passed in 1965, and that was kind of what it has been the legal basis for vote dilution claims. Before, I want to say the late 80s, people were running linear regression to try to bring these claims. And, with linear regression, if you're running that on aggregated data, obviously you're introducing bias. And so a lot of these, when it was applied in litigation, there was a lot of pushback, and folks just didn't really, there wasn't a lot of confidence on anybody's side, because you could, get like 110% estimated support for a candidate. So linear regression didn't work. People didn't trust it. Cases really, hinged on whether or not the judge bought LR. And then a guy named Gary King came around, and Gary King's currently a professor at Harvard. And he was the first to really solve this ecological inference problem. And I want to say in the late 80s is when that model was introduced to into the voting dilution world. And there was a rough start. He's revised the model a number of different times. I want to say 2 or 3. He's had 2 or 3 different versions. And now I want to say probably right around 2010-ish, that's when folks really started getting confidence in these estimates. So it's a fascinating question, because vote dilution as a doctrine really wouldn't exist were it not for these models. And these models have become better through just the scrutiny of being in federal litigation. And so there's been kind of an incentive for researchers to kind of tweak and so forth. So they've really kind of grown together over a period of about 20, 30 years. It's a really interesting story, actually.
Yes, thank you for running me through that. I didn't realize that. It would make sense, you're right, why linear regression wouldn't work, because it's unbounded. And
Right.
But then also how research from others has made this much more and more prevalent. And you pointed out even in this notebook that you're using a package that was developed by Karen Knudsen and somebody else. I'm forgetting their name just off the top of my head.
Yeah, Moon Duchin. Yeah.
And so they're professors that are working in the legal space, I assume, that are developing packages that folks like you are using outside of academia.
Yeah. So Karen, do you know Karen's husband is one of the developers on the PyMC team? I can't remember. Colin.
Yeah.
Yeah. So Karen. Well, I'll just say I haven't talked to Karen in a minute, but with Moon, Moon's really kind of unique in that she's developed this package and another Python package that folks like me, and it's a pretty small world who use these tools, but typically they're used by expert witnesses. I'm technically an expert witness that's in-house. Moon is one that testifies, and so she's involved in a number of different vote dilution cases. But she's really just kind of doing open sourcing it and supporting the community.
So then the second part of Daniel's question: do the courts have trouble coming to accept the results of this sort of model, the hierarchical binomial or models that are developed in open source? Have you had any issues with courts looking at the results of these models or rejecting the results of these models, or do they always tend to accept them, like you said, as expert witness testimony?
Yeah, they tend to be accepted. In fact, I haven't seen or heard of the results not being accepted, and I think that's just more a virtue of the facts on the ground, and not so much that these models are perfect. It's just where we're litigating in places where there's kind of very stark differences in voter preferences. So I haven't seen it, and like I said, if if I'm involved, and I think a lot of people think this way, if there's any gray area or room for interpretation where it's not obvious, they'll probably communicate that to the lawyer and they won't bring the suit forward.
Got it. So this is even done pre-trial, right? You're saying that before you even take this to court, you're running these analyses and informing the lawyers whether you will be able to take these things to court or not.
Exactly. Yeah.
Interesting. See, this is really cool because I think I'm a big fan of the PyMC examples, but a lot of them, let's say, are like Minnesota basement examples from 1980,
right,
or coal mining in the 1800s. And I think those things were quite relevant, right, in 1984 or the 1800s. But this is a really good example of where, with a U.S. election that's coming up pretty soon, and of course elections around the world that are even non-U.S., these sort of statistics are quite helpful in ensuring that people's voices get heard, and very timely, I have to say.
Yeah.
For the folks that are in the webinar still, feel free to ask questions anytime. If you're unable to ask on Discourse, just raise your hand in the Zoom webinar, and I can unmute you as well. But so far, I've only gotten questions from Daniel, so I'm gonna keep taking those. For a question of my own, Todd, with the statistical methods, are you going to? Do you need to develop these models further, or is this model working out quite well where you now have it down to a science, and every time this sort of thing comes up, you just pull out the same collab and you run it again with fresh data? So in other words, can you talk about where you're going to go next with these sorts of analyses, both with the model or maybe even outside of the model?
Yeah, great question. So, what's interesting about where we are at this moment is the law is anticipated to change. So at the end of this Supreme Court term, the Supreme Court will be weighing on a case called Milligan v. Allen, which is going to be basically ruling on vote dilution. And so the short answer is it really depends on how the court rules. If the court if nothing really changes in the law in terms of what the court needs to see in terms of preferences, then this model is good to go. I mean, it's a mature model. Like I said, it's been worked on by a number of really smart people over the past 20 or 30 years. It's finally to a point, like I said, where people can just bank on the estimates. There's really not a lot of doubt the way it used to be. Defendants used to be able to say, oh, well, it's just ecological regression and we don't trust it, and that sometimes get them pretty far, but it's not, they can't do that anymore. So we have a mature model, but what's interesting is the law might change, which it might require us to make a new model. So yeah.
And then the last question I have, if I see no others, is, granted that you said that the model won't change, being a statistician, I want to push and see if we can get the model to change somehow. But right now, this is a hierarchical binomial model, as you have mentioned in your talk, and we can see the model graph here from PyMC. Do you think there would be room, or that there's further research for, let's say, like additions such as like time series regressions of voter preferences or things like that? So maybe some of it may be due to voter suppression, but maybe some of this also may be time-dependent effects that you're not seeing if you just take one snapshot of votes. Have there been any sort of like extensions that have been proposed or thought about to look at more effects rather than just one snapshot of data?
Yeah. So one thing I didn't mention in the notebook was that we're looking at one election in this particular notebook, but typically we'll have 4 or 5 of these that we feel really good about the evidence and the confidence in the estimates. So yeah, I mean, with one, like you said, it's just one instance, but we typically try to have more examples of what we're trying to show. And the other thing that's interesting is this model is used basically high level to show that there's a problem in this jurisdiction. And it's really kind of independent of the way that districts are drawn and so forth. But one area that we're looking at that we really don't have a good solution for is kind of doing counterfactual analysis. So, with these estimates, are we able to tell a story about, how a jurisdiction's performance would change if we moved one precinct into a different precinct or changed the lines a different way? In other words, using the posteriors to, like I said, kind of do a counterfactual assessment of anticipating how a change in a jurisdiction would change, the potential outcomes, if that makes sense.
Yeah, it does. I mean, that does make sense that instead of just looking at the way things are happening, there's some value in changing and seeing what could have happened. That's part of the reason I had this question as well, because just across at least, statistics, and if we say Bayesian statistics, there's so many different ways to model either additional level effects like time we said, or other categorical effects other than race. But to your point, there also is more ways to ask questions of models, such as what could have happened if this was true, or if another thing was true, to get a sense of the data and then the reality. So it's really neat to hear that. I have a question here from Lucas that I want to read out loud. Lucas asks, great question. Who hires folks looking to use data science and other technical skills to advance progressive causes? I'm aware of a couple fellowship programs like the Data Science for Social Good, but I'm sure there's lots of places that people might not think of. So when you look around, Todd, what are other organizations such as yours that are looking to hire folks to do data science, sciencey things like this, to, I have to say, directly benefit society in a number of ways? What would you answer?
Yeah, good question. Unfortunately, the world is still pretty small. I got lucky, and to your question, Raveen, about like where are folks like maybe not looking. The way I got into it is working for an expert witness, and those are kind of hard to find. But there are almost always college professors that need help kind of doing the data cleaning and all the kind of the unglamorous stuff that goes into testifying. And so if you can find an expert who does, or a college professor who does expert witness work on any of the causes that you're kind of interested in on the legal side of things, that could be a really good way to get into it. I'll give a shout out to the ACLU. LDF, my organization, works pretty closely with the American Civil Liberties Union, and they've got an excellent data shop. I can't really think of any other orgs. Typically, it's one or two of us in on the legal side of things, but I wish I had more guidance for you, Lucas.
We got one more question from Daniel, and it's going to deep dive back into the model. Daniel asks, I was hoping to clarify how the model works a little bit. I understand the original data is aggregated, but there's trouble connecting individual votes to individual race data. Could you walk us through how the model circumvents this problem one more time?
Sure. So as you pointed out, Daniel, the problem is that we don't know, we can't tie an individual vote to a person. And so what we're trying to estimate is, at a geographic unit level, so basically a precinct, what percentage of, let's say, Black voters are supporting candidate A versus candidate B. And what the model is doing is basically saying, and really so much of the model's confidence comes from the relationship between the votes for a candidate and the percentage of a group. And so, for example, like when we're looking at Joe Biden, for example, Joe Biden had performed very well in the South. And if we were to go into Birmingham, for example, and see that, okay, there's probably about 10 predominantly Black precincts in Birmingham. Each are like 90% Black. And Joe Biden just so happened to get 95% of the Black votes in those precincts. The model is going to be pretty confident, in that assessment, as opposed to if it were like half and half and, Biden gets half. And so those instances where it's very kind of one-sided and the precinct's relatively homogeneous, the model, because it's hierarchical, is really kind of gaining confidence. The more of those it sees, the more it kind of is able to develop its confidence in the group estimates. And it's diametric in that, the more confidence you can get on Black voters, for example, the more confident you can be that, those votes for Biden, for example, aren't coming from white voters or Latino voters or whoever. And so I guess one way to think about it on the technical side is, what is it? It's called partial pooling. Is that right, Raveen? How the model gains confidence at the top level of the hierarchy?
Yeah, that's what we said.
Yeah. So, yeah. I mean, so again, those homogeneous kind of extreme situations where all of the votes are kind of coming from one group of people. That's where the model gets leverage on its confidence estimates, if that makes sense at all.
Yeah, that does make sense. And I again found this to be a pretty fascinating case because admittedly, even when I wrote my book, or we have hierarchical examples, we tend to use examples that are I don't want to say more theoretical, because some of them are still fairly applied, but they're more academic examples. This is, again, a really good example of the power of hierarchical pooling and how it's actually being used to influence like pretty substantial decisions. And frankly, even I didn't realize people were doing this until you submitted your PyMCon talk. So even selfishly, I'm really excited you did, because I feel a lot better about the next U.S. election, knowing that folks like you are working hard to use statistics to help inform what's going on, rather than just hearsay and things like that. It honestly gives me a lot of faith to know that things like this are being used to shape society, not just the sort of stuff you see on the news.
Yeah, well, what is it, radon in Minnesota basements?
Yeah. Yeah, I've seen that example a lot, and the 8 schools example is the other one I've seen a lot. So the classic hierarchical model being, well, the classic example of a hierarchical model being the 8 schools model, which is, there's nothing wrong with the study back then, but now the study is like 40 years old, so we just
right
over and over again. All right. Well, with that, we are pretty much at time for the Q&A. I don't see any other questions in Discourse or on Zoom, so I think we're good. If folks have other questions, we're always on. The Discourse is always there, so go ahead, go to the Discourse. If you're watching this in the future and you missed this webinar, go post your questions there, and somebody may come along and answer. I hope Todd will still be around, maybe and answer questions as well. But with that, let me just run through a couple logistics of PyMCon. So I think we figured out PyMCon. We're rolling now. So if you want to be a speaker, just like Todd, the CFP is always open. You can just go to PyMCon.com and submit your talk, whatever you would like to talk about that's related to Bayesian statistics that folks would be interested in, just like Todd has done here with voting rights. And then if you're interested in upcoming webinars, we haven't announced the next one yet, but you'll be the first to know. It's going to be Ricardo, and he's going to give a talk about PyMC development and I believe PyTensor. So that'll be coming in June. And then we have another talk scheduled in July as well about sports statistics with Max. So take a look at the website, stay on the meetup list and Discourse, and you'll be sure to get announcements for all of those. But for now, Todd, thank you again for taking the time to talk us through what you're doing with Bayesian statistics and with voting rights, recording your notebook and sharing that with us as well, and taking the time to talk to us through this webinar.
Thank you, Raveen, and thanks everybody for dialing in. It was fun.
Of course. All right. Bye, everybody.